Good morning, dear student. In previous lecture, we discussed the stereochemistry regarding the substitution in trans complexes, transoctahedral complexes. In this lecture, we discussing the substitution, the stereochemistry of the substitution reaction in the cis octahedral complexes. Again, there is the same possibility as the trans complex. That is case first, square pyramidal intermediate with retention of configuration, trigonal bipyramidal intermediate with B in trigonal plane results into two cis and one trans isomers. And in the third case, that is in trigonal bipyramidal intermediate with B at the axial position, we get two cis isomers. So same as that of trans complex. So the stereochemistry does not change with trans and cis complex. Either the complex is trans octahedral complex or cis octahedral complex. Whenever there is a square pyramidal intermediate and there is a retention of configuration, trigonal bipyramidal intermediate with B in trigonal plane results into two cis and one trans isomers. And with trigonal bipyramidal intermediate, okay, when B at axial position, it is not the part of the trigonal plane, then we get two cis isomers. So let us consider the stereochemistry with a representation. The first case, that is case first, square pyramidal intermediate, square pyramidal intermediate. So this is your complex, cis complex is there. This is your metal, this is your X ligand, this is your B ligand, and the remaining is your bidentate ligand. So this is your en, this is your en, ethylene diamide. Okay, after dissociation of this X, we get a vacant site, that is coordination number 5 intermediate, having geometry is square pyramidal. The geometry is square pyramidal. The geometry is square pyramidal, and this is your vacant site. Vacant site. So this is your square pyramidal intermediate, and the incoming nucleophile occupy the position of these vacant sites. So what you get here, M, this is your Y, this is your B, and the remaining like this. Okay, so En. So in this case we get a cis complex. So this is your the reactant having cis configuration, and the product is also having cis configuration. It indicates there is a retention of configuration when there is a square pyramidal intermediate. Let us discuss the second case, that is in which the geometry of the intermediate is trigonal bipyramidal, and the B ligand, it is the part of the trigonal plane. Okay, so this is as simple as it is. Okay, case second, that is TPP, okay, with B ligand as a part of trigonal plane, okay. So there is a two possibility, two cis and one trans. So this is the complex. We can consider this is the complex. This B, this is your X, okay, and this is your En, ethylene diamine, this is your En. Okay, after dissociation of X, the remaining ligands are arranged in such a way that we get the intermediate having trigonal bipyramidal geometry. Okay, so this is your metal, so this is the B. Okay, so they are arranged in such a way that we get the trigonal bipyramidal intermediate. So this is your En, and this is also your En. So we get this. Okay. This is your trigonal plane, and same case as we discussed in the trans complex. Okay, so it having a triangular plane, and each plane, okay, and the incoming nucleophile may be attacked from each plane of the triangle, any plane of the triangle. So it is attacked from this sides, it is attacked from this sides, it is attacked from these sides. So when, if you consider the first case, that is when it is attacked from the A side, B side, and this is your C side. So what is the product when it is attacked from A side? Then what is the complex, and what is their, we can say either it is cis or trans. Okay, which isomer is formed when it is attacked from this side of this triangle? Okay, so what you get here, this is your metal, and this is your incoming nucleophile, that is Y. Okay, and the remaining is like this. Okay, this like this. Okay, and this is here, this is your B. Okay, and this is your En, and this is also. Okay, when this attack from these sides, okay, A sides, so what you get here, this is your B, this is your Y, this is your En, and this is your En. Okay, so if you consider in this case, this B and Y are cis to each other, and therefore we get here the cis isomers. We get here the cis isomers when it is attacked from the front side. We can consider the first side, that is A sides, when it is attacked from the A side. So what is the product when it is attacked from the B side? So we get here, that is M, this is your Y, this is your B, and the remaining is like this. Okay, so this is the case when it is attacked from the B sides of the triangle. B sides of the triangle. So the B and Y are trans to each other, and we get this. This is your En, and this is also your En. Okay, so in this case, this B and Y are trans to each other, and we get the trans isomers. So you should keep in mind the ligands are rearranged itself in such a way that, okay, we get the product, we get the intermediate. After dissociation of the ligands are rearranged. Okay, they are rotated in such a way that we get the trigonal bipyramidal intermediate. And again, when there is the incoming nucleophile is attacked, okay, on any side of the triangle, they again rearrange in such a way that we get the product. So in the first case, when it is attacked from A side, we get cis isomer. When it is attacked from the B side, then we get the trans isomers. And what you get when it is attacked from the C side? So this is your A, this is your B, and this is your C side. Okay, so what is the product when it is attacked from the C side? So this is your metal. Okay, it is attacked from the C sides, and then this is your Y. Okay, this is your B, and the remaining is like this. The remaining is like this. Okay, so this is your En, and this is also your En. So again, in this case also, B and Y are cis to each other, and therefore we get cis isomers. Similar to that of trans isomers, whenever there is a trigonal bipyramidal intermediate with B ligand is the part of trigonal plane, then we get 2 cis isomers and 1 trans isomers. Okay, 2 cis isomers and 1 trans isomers. So let us consider the third case. Okay, the third case, that is TBP with B ligand is at axial position. TBP with B ligand as an axial position. The case third, that is B ligand at axial position. It is not the part of trigonal plane. Okay, and the geometry is again the intermediate with trigonal bipyramidal geometry. So this is your complex M, this is your B, this is your X, this is your En. Okay, and this is your En. So this is your cis complex. Okay, after dissociation of the X, we get the trigonal bipyramidal intermediate. Trigonal bipyramidal intermediate. Okay, so this is your M, this is your B, and we get this So we get this trigonal plane. Okay, and if you consider, this is your En and this is your En, and this is the plane. So we get this. So in this case we do not get a triangle because the side is it is occupied. This side is occupied on the trigonal plane. Okay, it is one of the side is occupied by this ethylene diamine. So there is only two possibility. So this is your A possibility, that incoming nucleophile attack from this side, and there is a second possibility that the incoming nucleophile attack from this B sides. And in both the cases we get cis isomers. So what is the product? So in this case we get this, that is M. Okay, this is your B, this is your Y, and the remaining is like this. So this is your En and this is your En. Again this B and Y are cis to each other, so we get cis isomers in this complex. And what happen when this attack from this B sides? Okay, when it is attack from this B sides, so we get this, that is M. Okay, this B is there. When it is attacked from this B sides, okay, when this is the case, that is it will attack from this sides. This is your Y and the remaining is like this. So this side is blocked, this is your En, and this is the case, this is your En. So again this is your cis complex is there. So this is your cis complex is there. Okay, so this is regarding to the stereochemistry in substitution reaction of octahedral complex, that is trans complex and cis complex. Same is the stereochemistry for trans also and cis also. So whenever there is a trans complex or cis complex octahedral complex, the stereochemistry does not change. Whenever there is a square pyramidal intermediate in both trans and cis complex, okay, trans and cis octahedral complex with square pyramidal intermediate, then there is a retention of configuration. We already discussed. In the case second, when in trans and cis both complex, when you considering the stereochemistry of trans and cis isomers of octahedral complex, then with a trigonal bipyramidal intermediate, when the B ligand it is the part of the trigonal plane, then there is a three possibility. Two are cis isomers and one is trans isomers. So we get three products with two cis configuration and one trans isomers, when the condition is that when the B ligand, whatever the B ligand, okay, of the complex or of the reactant is the part of trigonal plane. And in case third, again we get the trigonal bipyramidal intermediate, but whatever the B ligand, it is not the part of the trigonal plane, it is the part of axial ligand. It is the part of it will occupy the axial position. And again we get a geometry. Okay, again we get the intermediate having trigonal bipyramidal geometry, but in this case we can't get a triangle. So one of the side is blocked by this ethylene diamine ligand. So there is only two possibility, that the incoming nucleophile, that is Y, it will attack from the two sides of this trigonal plane, and we get two product with cis configuration. So this is all about the stereochemistry of substitution reaction of octahedral complex, that is trans complex as well as cis complex. In the next lecture we discussing the substitution reaction, okay, in the substitution reaction in square planar complexes, substitution reaction in square planar complexes. So this is all about substitution reaction in octahedral complex. In the next lecture we're discussing the substitution reaction in square planar complexes. So we are very much interested to study the trans effect and their application. Thank you.